I wanted to briefly talk about normal extravascular and intravascular destruction of red blood cells. %90 of red blood cell destructions occurs extravascularly. 5 to 10% of normal red blood cell destruction occurs intravascularly in the blood vessel. With extravascular destruction, RES cells phagocytize and then digest the components of the red blood cells, breaking it up into iron, globin, and protoporphyrin ring. That protoporphyrin ring is disassembled. Iron is gets bound to transferrin, and transferrin takes iron back to the bone marrow to make new hemoglobin. Globin goes back to the amino acid pool, and carbon is exhaled, and then bilirubinin's left. That's converted to bilirubin. Albumin binds to bilirubin to carry it to the liver. This in intravascular destruction of red blood cells, you just have your red blood cell in the blood vessel, and it ruptures and releases hemoglobin dimers. The hemoglobin gets attached to haptoglobin. That complex gets carried to liver cells. I'm not going to spend too much time going into free hemoglobin at this point, but just realize that pathologically, hemoglobin, if there's a lot of intravascular hemolysis taking place, this hemoglobin ends up not having enough haptoglobin to take it to the liver, so it can show up in your urine. That's not good. But anyways, going back to our normal red blood cell destruction, we're going to concentrate now, we're in the liver with this bilirubin that's now in the liver. Most of it came from extravascular destruction of red cells, but a little bit of it came from intravascular. In the liver, this bilirubin conjugates the bilirubin to a bilirubin glucuronide. It's then converted in the large intestine to urobilinogen and excreted in stool. Some of that urobilinogen, though, gets taken back up to the liver, filtered by the kidneys, and excreted in urine. So you can have a little bit of urobilinogen normally seen in your urine. Most of it, though, goes into your stool as a sterobilinogen is what it is called in stool. So also I want to make sure you understand unconjugated is the same as indirect, which is the prehepatic bilirubin. Conjugated is the same as direct or posthepatic bilirubin. So there's the paper for you to look at. And take notes from this video, look at it again, take your own notes, write it down so that you understand this process. Understand what normally happens is going to help you as we move into MLS 212 next semester. It's going to help you understand how it can go horribly wrong.